Welcome to 11.5, rotations in the coordinate plane. A rotation is a transformation in which a figure is turned around a fixed point called the center of rotation. They are also called turns. The rotated image and the original are the same shape and the same size, so they are congruent. In the picture below, you're seeing a rotation of a flag. The center of rotation is point A. So point A is what you are rotating about. These are clockwise rotations, meaning you're moving the direction which the clock turns. The first one is the original figure. The second picture, you see the flag is turned 90 degrees, about point A. The second, you see the flag is turned 180 degrees, about point A. And the last one you see is turned 270 degrees, about point A. So it's important to always start with noting whether you are going clockwise or counterclockwise. The only rotation that's going to be the same whether you're going counterclockwise or clockwise would be that 180 degrees. Sometimes it helps me to physically take my paper and turn it to see what I'm going to end up with. Try that with this next problem. It says draw the figure after each rotation. On page 528 under example 1, you will see a picture of an ice cream cone, which I've drawn here. 1A says 270 degree clockwise, meaning we're moving the direction which the clock turns, rotation about point C. And point C is the bottom of the ice cream cone. So I would start out by drawing your ice cream cone and labeling point C. I know I'm moving 270 degrees the direction in which a clock turns. I would, at this point, take your notes and physically turn it 3 sets of 90 degrees or 3 times and see what you are going to end up with. It'll help you to see your cone. So take a second, draw your cone, and turn your paper. See what you end up with. You should end up with your ice cream cone now facing this direction. That would be a 270 degree rotation about point C, the direction the clock moves. 1B wants you to take that same ice cream cone, move it counterclockwise, so now we're going the opposite way the clock turns, okay, about point C. But remember, I said moving 180 degrees is going to be the same whether you go clockwise or counterclockwise. Copy down the ice cream cone and your point C, and turn your paper clockwise or counterclockwise 180 degrees. You'll get the same picture. Both ways, you will get the ice cream cone is now upside down. The second portion of this lesson is talking about graphing on the coordinate plane. So again, for homework, you may want to use GeoGebra, you may use graph paper, or even print out a piece of graph paper so you can use that as well. Doesn't mean you can't use line paper, but it is easier to see on graph paper. If you turn to page 529 in your book, you will see the rules for each type of rotation. 90 degrees, 180, 270, both clockwise and counterclockwise. We'll write these up above this next question. So if I'm looking at 90 degrees and I'm going clockwise, we'll list that first. You're going to take your XY and you're going to switch them. So now you have YX, and the original X is now going to become the opposite sign. So if it was positive, it's negative. If it was negative, it's now positive. If you're moving counterclockwise and you're going 90 degrees, you're taking that XY, you're switching the places, and the original Y becomes negative. 180 degrees. Remember we said this is the only rotation that's the same whether you go clockwise or counterclockwise. So for both of these, you're going to take your XY and they both switch signs. So if they were negative, they're now positive. If they were positive, they're now negative. 270 degrees, clockwise, you're going to start off with your XY and it's going to become negative y comma x. meaning you're switching your x and your y, and your original y is changing signs. If it was positive, it's negative. If it was negative, it's now positive. If you're moving counterclockwise, your original point, xy, is going to become switched, and the original x becomes the opposite sign. If it was positive, it's negative. If it was negative, it's positive. You might see that there's a relationship between 90 degrees and 270. Well, if you know rotating around a complete circle is 360 degrees, 270 plus 90 completes your circle. So moving one direction 270 degrees, say clockwise, is the same thing as moving counterclockwise 90 degrees. You'll notice those two equations are the same. Just like moving 90 degrees clockwise, I could say is the same thing as moving 270 degrees counterclockwise. So you'll notice that both of those equations are the same. So 3 says a figure has these vertices, which I have already graphed. Take a second, pause the video, and graph it yourself. Make sure it looks like my graph. It says graph the figure and its image after a rotation 90 degrees clockwise about the origin. So I have a set of rules that I wrote up above. I know that 90 degrees clockwise is the same as 270 degrees counterclockwise. So I'm going to write out my coordinates. I'm going to have a new J prime, K prime, M prime, and N prime. I'm setting everything up, and then I will go to my graph. If my rule is 90 degrees clockwise, I know that my, xy are going to switch places, and the original x is going to become the opposite sign. So let's start with the first one. J was 3, 2. So the first thing I'm going to do is switch them. Second thing I'm going to do is the thing that was x before becomes the opposite sign. So I noticed the 3 was positive, it's now negative. Now look at K. I'm at 6, 4. First thing you're going to do is switch them. 4, 6. And then the one in the second position changes signs. It was positive, so now it's negative. M is at 6, 7. I'm going to switch places. 7, 6. And my original x, or the thing in the second position, changes signs. It was positive, it's now negative. My last one, N, was at 3, 7. So I switch it first. And the original x, or the thing that's now in the second position, becomes negative. Now I can graph. I'm going to go to 2, -3, plot my J prime, 4, -6, plot my K prime, 7, -6, M prime, and 7, -3, N prime. And I can connect my dots to see now that I have made a 270 degree rotation counterclockwise, which is the same thing as 90 degrees clockwise. So you're going to use these rules quite a bit. I will give them to you if needed on the test, but they are here. They're also on page 529. The last part of this lesson is talking about symmetry. If a figure can be rotated less than 360 degrees about its center, so that the image matches the original figure, the figure has what we call rotational symmetry. So I took this flower directly from your book. The question says, does it have rotational symmetry? If it does, describe the angle of rotation. Well, the reason it has to be less than 360 degrees is if you rotated something 360 degrees, you actually didn't change it. It's staying exactly the same. So I know that my angle of rotation has to be something between 0 and 360 degrees. So let's look at the center. This right here would be the center of my figure. Again, I like to actually physically take my notes and turn it to see if it rotates on top of itself. I notice that all three of this flower's petals look exactly the same. So if I turn it one petal width, I'll notice that I end up with the exact same thing. So I would say, yes, it does have rotational symmetry. To find your angle, we'll look at how many things are identical. I said that each individual petal here is exactly the same. So I'm going to take that 360 degrees and divide it by 3 separate petals. Every time I turn my picture 120 degrees, I get the same exact picture. It looks unchanged. So I would say my angle of rotation is 120 degrees. So now, like I said before, please use graph paper or GeoGebra or print off some sort of graph paper. You can use line paper, but it is way more difficult, so I suggest you use graph again today.